Okay, Algebra 2, Day 4 notes. This is the review chapter. Day 4, again, it's kind of all over the place. This is all about exponents and exponent rules. All right, the first page is like in general, all the rules. We'll do some examples on the next couple pages. The notes are kind of lengthy, so we're going to do some together, let you finish some of them on your own. Let's start right off the first one. Multiplication law. If I have x to some a times x to some b, this is actually a typo right off the bat. Cross that off. It's not x to the a, b, all right? If the base is the same, right, x is the base, a and b are exponents. If the base is the same, you can add the exponents. So it should be x to the a plus b. All right. Quick example, x to the third times x to the fourth. All right, as long as the base is the same, in this case it's an x, you can add those. That is x to the seventh. The power rule. All right, this is if you have x to some exponent and then raised to another exponent. Zoom in so you can see it, maybe that would help. So x to the a raised to the c kind of gives you the answer. It is x to the ac, so you're just multiplying the exponents. Example, x to the third all raised to the fifth is x to the 15th. All right, for division, a little bit different. All right, again, x to the a divided by x to the b, you subtract the exponents. So as long as the base is the same, you can subtract them. This one's x to the fifth. All right, again, it's top minus bottom. This would be x to the negative fifth. We'll do negative exponents a little bit more in a minute. All right, at the bottom of the page, power of a product law. All right, fancy name for xy to the a. You can essentially distribute that a to both terms in here. All right, that's different than if it was x plus a, or x plus y to the a. So be careful, it has to be multiplying here, no plus or minus inside. So if I have xy to the fourth, that is x to the fourth, y to the fourth. All right, those are some basic rules. There's lots of examples on the next page. All right. There's one more, the quotient rule again, I guess. You could distribute that through as well. So if you have xy, or x divided by y to the third, that's the same as x to the third over y to the third. All right. Make more sense the more examples you do. Instead of memorizing all those rules, just practice. All right, let's do some of these on this page. I'm not gonna do all of them. We'll do some. Number one, all right, identify what you have. Same base, add the exponents, x to the ninth. Let's skip to number three. Number three, same idea, except now I have a coefficient. There's 3. So I have 3x to the fourth times 5x. Coefficients, you multiply those, just like usual. So that's 15. And then you still add your exponents. So if there's no exponent, remember that's a 1. You can write it in if you want. Most of you just go with it, that's fine. So that's 15x to the fourth. Something else, number 4 is the other rule. All right, this is a power to a power. You're gonna hear me say that a couple times. So this is where you multiply, a to the sixth. Number 5, 5x cubed all squared. So be careful. So some people make mistakes. Since the parentheses are around all of it, you have to do 5 squared, which is 25. All right, it's not 5 times 2. Be careful. And then your power rule, power to a power, you multiply. So 25x to the sixth. All right, let's try number 7. Division. You actually divide the coefficients. That's 5. Subtract exponents. So x to the sixth. All right, they get a little more to it, I guess. Number 8, simplify before you try to find the final answer. So on top, I can say that's y to the fifth. On the bottom, that is y to the sixth. Simplify that. So you could say that's 1 over y. You could also say it's y to the negative first. Same thing. There's a few of these in here that have just numbers, no variables, like number 9. All right, you don't have to find the final answer. Just leave it as 5 to something. So simplify this all out. Well, this is 5 to the 11th. Over 5 to the 9th, all right, which is 5 squared. You can just leave it like that. Obviously, you all know what 5 squared is, but that's fine. Leave it like that. Let you try some of these other ones that we're leaving blank. All right, fill them all in. We'll go over them the next day in class. Anything else on here is challenging? Let you try the rest of these. All right, number 13, maybe a little bit more challenging. Give it a shot. Try them all. Number 16, does negative x squared equal negative x squared? Parentheses matter, right? So show me an example that doesn't work or does work. I don't know. Try it. Next page. Multiple choice. Try these. All right, let's check 19. 19 looks messy. The expression b to the 2n plus 1 cubed divided by b to the n times b to the 4n plus 3 is equivalent to which of these? Let's simplify this mess. I'm cubing this. So this is a power to a power. So this should be b to the 6n plus 3. Right, multiply those. Divided by, rule down here, I have the same base, I'm going to add exponents. So n plus 4n is 5n plus 3. No, this is just division. So subtract exponents. 6n minus 5n. It's going to be b to the n. 3 minus 3 is gone. So b to the n. Hopefully that's a choice. Choice 2. All right. 20, you try those. Make you think a little bit. The expression 5 times 5 squared is equivalent to which of these? All right. Is it 25 squared? Hopefully you didn't do that. This is 5 to the first times 5 to the second. I would say that's 5 to the third, because I can add exponents. This is your base. Leave that alone. Choice 2. All right, a lot of those you can use a calculator on. Check them out too. Next page. The zero exponent rule. Anything to the 0 power. Remember this from algebra 1. It's 1. All right, doesn't matter what it is. Anything to the 0 exponent is 1. Negative exponents. A lot of you forget about your negative exponents. All right, we do a little bit with negatives, not too much. If I have x to a negative number, maybe you can see that. It's really small. You can essentially flip that over, make it a fraction. So flip it 1 over. Now it's x to the positive a. This is the same thing written differently. All right, another way to write this, you could just say this is 1 over x all to the a, because the one on top's not going to change. Different ways of writing the same thing. Division works the same way. All right, if you have x over y all to the negative a, you could distribute it through maybe. This is a different one way to write it. X to the negative a over y to the negative a. But if I have negative exponents, even if it's in the denominator, I can flop this, right? So the x is to the negative a, I can put that in the denominator as a positive a. If it's already negative in the denominator, I can put that in the numerator as a positive a. Just flip it. It changes the sign of the exponent. Another way to write this is just y over x all to the a. So all the same thing written differently, a little bit different. Some easy ones. Simplify anything to the 0 is 1. Be careful with this over here. The y to the 0 is what's being raised, right? The y is being raised to the 0. 33 has nothing to do with that. It's just 33 times 1, which is 33. So not everything is the answer, but so be careful what you got. At the bottom, write an equivalent expression using only positive exponents. All right? So try number 1. Number 2, I would say k is to the negative 4th, not the 3. So I'm going to say this is 3 over k to the 4th. Now it has positive exponents. Good to go. Last page, a couple more examples. Try to write all these with positive exponents. Again, if you have a negative exponent here, you could you can do a bunch of different things, right? Say you want to do, you could do this. This is 1 over 5y to the 3rd now. Same thing. If you want to simplify further, you can. What's that, 1 over 125, is that right? I don't know. Same thing. Right, if it's already negative in the denominator, you can bump it to the numerator as a positive. Try the rest of those. We'll go over some answers in class, all on exponents.